Okay, so let's start the lecture 2 for aesthetics during the summer. Um, let's pray. In the name of the Father, Son, Holy Spirit, Amen. Direct, O Lord, we beseech you our actions by holy inspirations, and carry them on by grace's assistance, that every prayer and work of us may begin always from you, and through you come to completion through Christ our Lord. Amen. In the name of the Father, Son, Holy Spirit, Amen. So I have been trying to make the second screen work, but whenever I share the screen of my iPad, I can't see the chat anymore. So I still need to figure out a few things. So today, once again, please stop me anytime. I cannot see you, um, but I can hear you. So stop me anytime um, that you have a question. Okay? If you have your calculator there, you're working with me, please take your calculator right now. We're going to do a lot of problems today, a few examples. I'll try to give at least 1 minute for you to figure it out. So if you are watch the recorded lecture, please stop, try to work the problem by yourself. As I made you guys last night, I create a playlist of all the recordings. So once the record is is done by Zoom here, I will post it on YouTube, and then you guys can check the playlist for new updates. Um, what else? I think that's it. I believe we're going to do a lot of things today. Maybe start lecture 2, like the notes for lecture 2. We may finish, may not. Let's see. Okay, which is not a problem. All right, so jump to it. Last class yesterday we talked about mainly about vectors. Okay, so let me see here. So we talk about vectors, and we have been working with two-dimension vectors. And once we have this two-dimension vector, meaning this vector has an x component and a y component. Okay, and how can we find those components? Okay, we can change this vector to two components. As I said, one in I, one in j hat. Okay, meaning one in x-axis and one in y-axis. And how can we find it? Well, we need to use the magnitude of this resultant vector, this vector, and also use the direction of this vector, meaning using the magnitude and the angle of this vector. Okay, and for this particular case, as I mentioned to you, for this particular case where we have the angle theta close to the x-axis, we figured it out that one's going to be the sine, which is the fy, another one's going to be the cosine, which is the fx. And I mentioned that this is going to change depending where this angle is. Okay, if I'm going to give you this angle here, alpha, then things going to change. The sine and cosine is going to flip, and we're going to see in today's class. Okay, so pretty much what we finished the class was doing one problem where you could see the vector and also its direction. And what we did, we translate this vector to Cartesian notation, meaning an x-axis projection in x-axis and a projection on fy and y-axis. Okay, and we use the angle, and of course we use those quadrants. Remember, so this is the positive direction, so that's why this fx is negative, because it's going to the negative direction of x. Okay, I got a question from one of you guys by email about, Bruno, are we working this class with degrees instead of radians, or there is any way that we're going to work with radians? It is a good question. Right now in this class, in this course, we're going to work every single time with degrees, okay? Because degree is going to give us the direction, okay? Next semester or in the future class, when you work with solid dynamics, sorry, this mechanic of solids and dynamics, most of the time when you talk about rotation, then we're going to talk about radiance, okay? When you're going to talk about torsion, okay? We're going to talk about rotation. Rotation and radiance, sorry. We're going to use radiance. But for this class, most of the time, I'm going to be working with degrees, okay? So maybe you are trying to figure it out with your calculator and you couldn't because of your calculator is in radians, okay? So just pay attention on it if your calculator is in radians or degrees, okay? Make sure it is in degrees, okay? Before I continue, let me try to just show at least a screen here. Let me see if it's gonna work now. Okay, maybe. Okay, let's keep going. So today we're going to continue here. So continue the lecture. We're going to talk about now additional force, meaning that we have a bunch of force. As you can see here, we have F1, we have F2, we have F3. And each one of those force or those vectors, okay? I mean, I'm talking about force because in this class, we're gonna always talk about force, okay? So when I say force, is the vector force, okay? So each one of those vector force vectors, we have components, x and y, x and y, x and y. And how can we sum all of them in a way that we're going to, at the end, okay, we're going to jump from this to this one here, meaning that we sum x, right here, we're going to sum x, x, and x, and we're going to have this resultant. Same, we're going to sum y, y, and y, and we're going to have this resultant in y. Okay, and how can we do that? Well, this is very good because we have x and y component. So in this way, it's much easier to sum different force vectors. Okay. Yesterday, I mentioned of a summation of tip and tail. You just put those, and then you're gonna have some resultant. But most of the time, that one, then you have to work with angles, with law of cosines, law of sines, okay? But once we convert the vector to x and y component, it's much easier to do the summation, to add vectors and have the resultant. So that's what we're gonna do right now, okay? So if you see this problem right here, we're gonna work with this problem, example number 2, okay? So let's jump to it. We have vector P and vector Q, okay? Vector P and vector Q. And right here I can see their magnitude, 40 newtons, 60 newtons. We have some angles here where we can figure it out the direction. Well, that's pretty much what we need to transform those vectors to the Cartesian notation, meaning the x and y component, okay? So, for example, let's talk about vector P first, okay? So vector P. What is the polar notation for this vector? Okay, meaning, what is its magnitude? Magnitude, 40 Newton, okay? Everybody agree? What is the angle? What is the direction of this vector? 20 degrees. Okay, so far so good. Now, how can I write this vector in Cartesian notation? Meaning, what's going to be the x and y component? Well, I know for sure that x and y is going to be 40, the magnitude, some angle, sine or cosine, and then it's going to be also 40, sine or cosine. This is going to be I hat, this is going to be j hat. Okay. Now, two things that I need to figure it out. Which one is going to be the sine? Which one is going to be the cosine? Okay, sine, cosine. That's the first one. Where is going to be the sine? Where is going to be the cosine? And second thing is I hat, j hat, meaning the x component, y component. They are positive or negative. Okay, so two things that I need to figure it out here: sine, cosine, positive, negative. Okay, let's see in this case. If we consider this right here as my orange right here, okay, and we're going to talk about the vector p, okay, we're going to have this projection here, which is going to be px. I'm going to have this projection here, which is going to be py. Okay, and we are talking about this angle here, theta, okay, 20 degrees. First of all, I think much easier to visualize. If this is x, this is y, what about positive, negative? Px is going to be positive or negative? It's going to be positive. Okay, why? Because px it is on the x, the positive x direction. Okay, going to that direction, positive. What about py? Well, py is also going to the positive direction of y. So py is going to be also positive. Okay, good. One thing is good. Now, what is going to be the sine? Which one is going to be the cosine? Well, this is pretty much the example that we worked yesterday, right? The angle is here. Okay. What is going to be this? What is sine? Sine is opposite adjacent hypotenuse. Okay. This is the sine. Sine of 20 is going to be this one and that one. And when I'm talking about this direction here, this length, this represent what? Py. So for this case, py is going to be the sine. Oh, sorry. Pi is going to be sine. Sine of 20 degrees. Cosine. Okay, let me put it here. So, once again, cosine. Cosine adjacent right here, and this one here. So cosine is going to be y. Okay, and let me tell you one thing here. Okay, let put 20 degrees. There is a way that I like to say to students for you just to visualize it and get it done. Meaning that you see 20 degrees here? This 20 degrees, this angle, is touching in which projection? The 20 degrees is touching on X projection. Can you see that? Okay, let's just visualize this. 20 degrees right here. From where I'm measuring the 20 degrees. I'm measuring the 20 degrees from px, okay, from the x-axis. So this 20 degrees is touching the x-axis. So whenever this degree, the angle is touching px or x direction, okay, this is going to be the cosine, okay, and the other one is going to be the sine. Now, if my angle was measured by the y-axis, then the y would be the cosine, okay? we're going to have a problem in a moment, so you're going to visualize it. But just keep in mind, the sine and cosine is going to change a few times, okay? It's not always x is cosine and y is sine, okay? I just want to emphasize it. I just wanted to put it in your mind, because some of the mistakes that I see students doing is like they see the angle, they just go cosine sine, x cosine, y sine, and it's not like that always, okay? It change, okay? So so this is my p vector, sorry. Once I do this calculation, okay, you can do it right now, 40 cosine of 20 degrees, okay? Make sure your calculator is on degrees. If it is not, let me know after class. I can help you to figure it out how to change it. So it should be in degrees, and we're gonna get 37.59 I had. For this one, positive 13.68 J hat. So this is my P vector with X and Y component, okay? Any questions? All good? Okay, I'll keep going. Q vector. Now, what is the magnitude of this vector? 60 newtons. What is the direction of this vector, guys? Direction of this vector. Anyone has a guess? Let me see if I can.
25.
25?
Mm-hmm.
Let me just see if I can come to zoom on my cell phone. I'll try it later. Okay, 25, I have an answer of 25, which is not, okay? It's not 25. The direction is measured from one of the axes, okay? So right here, this is the direction of Q, okay? This is the direction of Q, meaning that this one here actually is 45 degrees. Its direction from x-axis, okay, it is 45 degrees. Okay? So pay attention on that. This 25 degrees is just from P to Q, but the direction is measured from x-axis, okay, 45 degrees. Now, with that in mind, once again, Q is going to be, where is my Q projection? Can I do the projection here? Maybe too much information, but Q, X, and Q there, QY. Both of them, we agree, they're in the positive direction. So positive, positive, I hat, J hat. Magnitude, 60. What is sine cosine? Well, just following the same logic, 45 is measured from x-axis, meaning that this is going to be the cosine of 45. This is going to be sine of 45. Okay? However, 45 doesn't matter. Sine and cosine are the same. Okay? But just for you to visualize. Q is 42, 43. I hat 42, 43. J hat. Sounds good? Okay. Now, I'm not done. I just wrote the vectors using Cartesian notation. I want to find the resultant. Can I put it? Can put it here down. The resultant vector. Once I sum those two vectors, what's going to be the answer? Okay. What should I do? Well, I have two vectors, x and y. I'm going to sum x with x, y with y. Okay. I like to say apples with apples, orange with oranges. Okay? That's what I'm going to sum. X, X, Y, and Y. Okay? And also respecting the sign of them. Here, both of them, PX and QX, they are positive. Okay? If one of it was negative, I bring the negative together. Okay? In this case, once I sum it, it's going to be 8002. And then this one here is going to be 5611 J hat. Okay? What is the unit? Newtons. Okay? So that's how I sum vectors using Cartesian notation. In this case, when I sum, I find the resultant of those vectors. Any questions? No? Okay. Let me ask another thing here. I found the resultant of the vectors in y and I hat, j hat, meaning x component and y component of the resultant. But if I ask you, let me here, right here, and I think I asked this question in the homework. What is the magnitude of the resultant? And what is the direction of the resultant? Because right now I have the components of the resultant. But what is the magnitude? Okay, I think I asked this, I'm asking this for the homework. What is the magnitude and what is the direction of the resultant? Meaning, I have the components. Let's change to just one vector, the resultant of those two components. Let's bring it back. How can I do that? Do I have space here? I'll try to draw right here. So for example, in Y, I have 5611. In X, 8002. Well, my resultant is going to be this one here. Resultant. Okay? With the X component and Y component. Okay? And what's going to be the direction? Well, the direction is going to be this value right there. Take a look, what do we have here? Right angle triangle. How can I find R if I have a right angle triangle? Okay, what we mentioned yesterday? R square 8002 square plus 5611 square. Like this. R is going to be the square root of those guys there. Okay. At the end, I have here 9773 newtons. Okay, so the magnitude of R is 9773 newtons. What are its components? In X, I have 80.02 and Y 5611. But the magnitude of R is 97.73. Going to that direction. Which direction? Well, then you can use angles to use. So katoa. You can use sine, you can use cosine. What I like to use is tangent. Okay? Tangent of theta is what? Opposite 5611 divided by 8002. Okay? This angle is going to be tangent minus 1, or inverse of tangent of that one, 5611, 8002. The angle is going to be, I have here 3504 degrees. Okay? So once we sum those two vectors here, okay, once we sum those two vectors, we're going to have a resultant of 97 going 35 degrees. meaning that 35 degrees is, if this is 45, let's say 35 is right here, it's going to be around here. Let me use another color. So this is going to be the resultant around here, resultant, okay? But to get there, first we change to x and y component, and we find later the magnitude and direction, okay? Most of the time, down the road, we're gonna stick only here on the components, okay? But it's good for you to remember or to learn how to change back to magnitude and direction, okay? And once again, guys, if you don't have time right now, uh, go after class, try to type those things, okay? Try to find those same number using the square root, squares. This one is very, very important. Make sure you got a 3504. Maybe your calculator is in radians, not in degrees. Okay, make sure you know how to do this calculation. Okay, sine, cosine, tangent. Okay, how to type it. Many mistakes come from typing the calculator. Okay, any question? All good? Okay, let's go for another example. This one, much bigger, and we have different angles here. So that will be great for you to understand. If you got this one, you are all good. Okay, if you can see this one, you are good for this part of the class. Okay, so right now we have four forces acting on both A. We need to find the resultant of the force, meaning once we sum all those force going to the right, going to the left top, going down, going to the corner, down, we have four forces. But what is the resultant? What from which force? What the resultant of those force and which direction if they are pulling it? Okay. How can you find it? Well, the easiest way when we have more than two forces is what we just did. Okay. X and Y components. Let's sum X with X, Y with Y. Okay. And let's solve it. So let's start. Let's do that. Um, let's see how can I save some space here. It'd be great if I have more space. So let's start here. F1. Let's write F1 vector. Yeah, let's write F1 vector. What do we have for F1? Okay, let's take a look here. F1, we know its magnitude 150 newtons. Blue one, 150 newtons. What is its direction? Well, we have 30 degrees here. Measure from the x-axis. All good. Awesome. So if I put it here, the components, I know that this is F1x. This is F1y. Okay. By the way, I'm just drawing this outside the axis just to save some space or not get confused. But this should be on top of y, on top of x. Okay. Just to clarify. Well, so both of them are positive, going to the positive direction, okay? Meaning that this is going to be 150, okay? Positive sine or cosine I hat, positive 150 sine or cosine j hat, okay? Now let's figure it out the cosine sine, okay? Let's use that rule. Let's use that rule. Let me see if I can draw it here for you so you know what I'm saying. If we have this angle here, this is F. Say we have this angle theta. Angle theta measured from the x-axis, touching the x-axis. So this is going to be F cosine is going to be F sine. However, this is different. This is different if the angle is measured from the y-axis. If the angle is measured from the y-axis, this one is going to be F cosine. This is going to be F sine. Okay, so that's the difference that I want you guys to always pay attention. Okay, always pay attention. Coming here, x axis touching the 30 degrees. So what we have is cosine of 30 sine 30 degrees. Both positive. Okay, let's go for F2. F2, where is F2? Right here. Take a look in F2. This one, F2y. This one here, F2x. Magnitude, 80 newtons. X going to the negative direction. So I have negative 80 newtons. Okay. And y going to the positive. So positive 80 newtons. Now, what is sine and what is cosine? Take a look at this problem here, guys. 20 degrees. 20 degrees is touching the y component, y-axis. Okay? Meaning this example right here. Okay? So, this one is going to be now sine of 20. And this one is going to be cosine of 20. Okay? And why is that? Because once you close the triangle here, okay, and we do, what is sine? Sine is opposite, okay, F2, hypotenuse, 80 sine 20, okay? Now, can I open parentheses here? Some students ask me, Bruno, can I, instead of using 20 degrees, can I use 70 degrees? And then this would be cosine of 70. And this would be sine of 70. Can I do that? Yes or no? What do you guys think? The answer is yes. Yes, you can. Okay? Because they are complementary angles. Okay? 70 and 20 degrees. If you don't know that, type in your calculator sine of 20. I see here 0.34. Then you type cosine of 70. I see 0.34. They are the same. Those guys here are the same. Okay? Sine of 20 is the same as cosine of 70. Cosine of 20 is the same as sine of 70. Okay? So yes, you can do that. You can. Then you're going to work just with this case here. Okay? Always measuring from x-axis. Okay? Now, it's just one more step for you. Okay? Find the other angle and go from there. Myself, what I'm going to do in class, I'm going to always use the angle that is given. Okay? But feel free in the homework, how you solve the problems, to find the other angle and use it. Okay? But what I want to see is if you have sine, cosine, right. Okay? So this could be the same. I'll be using the 20 degrees. Okay? I'll keep using what is given to me. Now, let's jump to F3. F3. Guys, take a look. Where F3 is? F3 is on top of y-axis. Of course, going to the negative direction, but it's on top of y-axis. Okay? Meaning that what is x component? What is the x component for this one? None. 0. Okay? This is 0 I hat. We don't have x component because all of the vector is on top of y. Okay? And what is the y component? Well, y component is just 110 negative. Okay? I have no angle. It's just that one. Okay? It's going to be that one. All right? So my full vector is in the y component. So all of that magnitude is going to be in the y component. There is no angle there. Okay? There is nothing on x direction. And y is negative because it's going to the negative y direction, going down. Okay? What about F4 vector? Once again, I have 100. I hat 100 j hat. Positive or negative? X positive, y going down, negative. So this is positive, this is negative. Okay? 15 degrees is given to me, is touching, is measuring, it is measured from x-axis, meaning that this is going to be cosine, this is going to be the sine. Okay. Just like that. Measure from where? X-axis, cosine, sine. Okay? Save some time. Okay? Can save some time. Now, how can I find the resultant? Well, I'm going to sum those guys and those guys. Get the sign here. Okay? I'll leave with the result here. Then you guys can type it, see if you can get the same. Okay, it's going to be your job. 199.13 positive 14.3 J newtons. That's the resultant. Any questions? No? All clear? Did you guys get this sine cosine thing? Okay. So I'll keep going. Next problem. Times it. Okay. If, now a little bit different, okay? If the resultant force acting on the bracket is to be 750 newtons, direct along the positive x-axis, determine the magnitude of F and its direction. Okay? So let's see what it's saying here. It's saying that the following. If the resultant force, so it's talking about the resultant force, is to be 750 newtons. So it's already giving to you the resultant magnitude, the magnitude of the resultant. And then also the direction along the positive x-axis, meaning that the resultant should be right here. Okay, this should be the resultant along the x-axis. And also give the magnitude, 750 newtons, 750 newtons. Okay. Now, He's asking not the resultant, because the resultant is given to you. He's asking, hey, about this force F. What should be the magnitude and direction of F so we have this resultant? You see, it's a little bit different, the question here. Okay, kind of the approach is kind of the same, just the question is a little bit different. So what do we need to do first? Well, let's find x and y component of those force. Okay, to help us here, let's say this one is F1, this is F2, and this is F3. Can we do that? Just so we can keep tracking the force. Okay, so let's start. Let's start with F1. We don't know much of it, but we can have some information for sure. F1 vector. What is its magnitude? Well, we don't know. Say F1. F1, I hat, F1, J hat. Okay. Its components. It's going to be positive or negative. Well, F1 here, X and Y, both of them positive. Positive, positive. So far, so good. The angle is measured from the x-axis, meaning that this is going to be cosine of theta. This is going to be sine of theta. Okay. This is what I can write about F1. Okay. Please stop me if you have questions. Okay. F2. Okay. Well, Bruno, F2, I know that its magnitude is 325. 325. I hat, J hat. Its components gonna be right here, right there, both of them positive. Positive, positive. Now its direction, well, wait a minute. Where is the angle of this force? What is this angle? Alpha. In what the heck is this one here? What's happening here? Okay. So guys, I don't know if you have seen it before in physics or any place, math. And every time we work in a vector and we see like this triangle with some numbers, it's just saying that this triangle that we can draw with the components, okay, is the same as this triangle here, meaning that the following. Take a look. These would be 13, 12, 5, 13, 12, 5. This angle alpha is saying that this angle here is the same as this angle alpha. Okay, alpha. Meaning that if we find this angle using this triangle here, we found this angle here. Okay, so that's why we have sometimes this triangle drawing over there. Okay, it is because similar angles. Okay, it's similar. Now you have two options here. Okay, and you're gonna see, by the way, you're gonna see during my lectures that I like to give options to students, because sometimes one student like one thing, the other student like the other thing, think differently, approach the problem in different ways. So I really don't care which approach you use. Okay, I care if you understand, if you are comfortable with your approach. So I'm always talking about, as I said, I'm okay if you use sine of 20. I'm okay if you use cosine of 70. I just want you to understand and take the approach that you like, okay, that you are comfortable. Sounds good? So a few times during my lectures, you're gonna see, hey, you can do that way, you can think this way. Okay, it's up to you. I have the way that I'm gonna stick during the classroom, okay, during the lecture, but feel free to use your way to solve homeworks, to solve the problems, to solve the exam. All good? Close parentheses. So for this one here is the same thing. This one I can come here and find the angle. What is this angle? Okay, well, let me actually go out already. Tangent of alpha is 12 divided by 5. You're gonna go alpha, tangent, inverse tangent. It's gonna be that one. Alpha here in my notes, I have 6738. Okay. I am allowed to say 6, 7 without you guys laughing about it. Last fall was really fun. Okay. Every angle that was 6, 7, the guys went crazy in classroom. Okay. So this one, 6, 7, 6, 7 degrees. Okay. I can find the angle like this. Okay. And then I'll go here and just write the following. Cosine 6, 7, 38, sine 6, 7, 38. Do you guys agree? All good? Okay, let me show you another way to solve the same problem. Okay, to solve the same problem. Now, I can come to this triangle here, and actually I can already find the cosine and the sine. Okay, I can already do that. How? Because I have the dimensions. For example, what is the cosine? Sorry, what is the cosine of theta? So not theta, alpha. We are talking about alpha here. Cosine of alpha. Remember SOHCAHTOA? It's gonna be the adjacent divided by tenus. And what is the sine of alpha? 12 divided by 13. Bruno, are you saying that I can change this guy, all of this guy here, to 5 over 13? And I can change all of this guy here, 12 over 13. Let's see if it is true. Don't know if you have your calculator. Let's type cosine of 67.38, 0.38. That's what I got. 0.39, depending how you round up. Then I'm going to do 5 divided by 13. Ooh, 0.38. Okay, exactly same thing. Okay, so right here, another option for you. You can find the angle, write cosine of that angle, or you can use the dimensions of that triangle and already have the answer. 5 over 13, 12 over 13. Okay, and again, I'm substituting this part here. Of course, I have 325 times 5 divided by 13. Sounds good? Once again, I'm giving two options to you. You decide what you want to use. Okay? All good? I hope so. F3. Please stop me if you have questions. F3, 600 here. 600, 600, J, I. Take a look in its components. Positive, negative. X positive, Y negative. Once again, angle measured from the x-axis. So I have cosine 45, sine of 45. Okay? Once again, sine, cosine of 45 are the same. However, I really want to see you writing cosine and sine in the right place. Just for me to see if you're understanding it. Okay? Guys, once you sum this, We already know what we have to get. The resultant is given to you. Remember, we have 750 I hat, and this should be 0, 0 j hat, because it is along, okay, the positive x-axis. This should be the resultant. Sounds good? Right here. Okay, can we solve it? Can we solve it here? Let's sum it. Let me sum it right here. Save some space. Where here I have f1 cosine. I have 125. Once you do that, and I have 425, 26. And right here I have f1 sine plus 300, 424, 26, 0. Okay? Once we do that, we're going to have the following. So again, just saving really quickly here for all of us. f1 cosine 274, f1 sine 124, 26. Okay, so these should be the components for f1 sine and cosine. And actually, how can you find f1? Okay, let me go this way here. If f1 is right here, as we know, okay, f1 here, we said that f1 cosine is the x component. So right here we have f1 cosine, okay, which is going to be 274. And this one is f1 sine. It's going to be 124, 26. We have the angle here, right angle triangle. Okay, we're going to have f1 square root of 124, 26 square plus 274 square. Okay, what I'm gonna get, f1, solve it quickly here, 236.09 newtons. Okay, that's the magnitude of f1. Okay, so first I found f1 cosine, f1 sine. I know that they are components of f1 right angle triangle rule. Okay, I found 236. Okay, and then now just pick one of those here and find the angle. So let me pick the first one. Okay, let me pick the first one. First one, f1 cosine should be 200. Cosine of the angle should be 274 divided by 236.09. Angle should be cosine inverse 274, 236.09. At the end, angle here in my solution, 31.76 degrees. Then F1 should be 236.09 newtons. Its direction should be 31.76 degrees in order to have this resultant as 750 newtons along the x-axis. Okay, guys? Questions? Questions? No? All good? Let me see. This problem is pretty much the same. So I'll leave this problem for you to solve, okay? I will solve later this problem and post on Brightspace, but I will give you time for you guys to solve it, okay? Now, let's stop here for this lecture and let's jump to lecture number 2, okay? But before that, can we do like a 5 minutes break? Okay, I'm gonna stop the um, recording right now and then we're gonna come in 5 minutes. Let me see here. Okay, we're back. Okay, guys, now I'll start lecture number 2. The notes, lecture number 2. Okay, so up to now, what we did was working with vectors and x and y components of those two-dimensional vectors. Okay. However, we're going to continue building on it. Okay. We're not going to just work with some in vectors. We want to achieve something else. Okay, with that. And that comes this lecture. We're going to talk about today, this part right now, the equilibrium of a particle. Okay, equilibrium of a particle in 2 dimensions. And what is a particle? A particle is a size and shapes of the body are not significant. Okay, is when the size and shape of that body is so small, like a point. Okay, and all of those force may be assumed to be applied at a single point. So we can assume that one thing is going to be a particle when the shape, the body doesn't matter. Okay, all of those forces are going to be applied at the same point. Okay, so pretty much we are talking about in the same point we have F1, F2, F3, and that's pretty much what we did right now. Okay, and there's those problems with what was it, the bolt, the bracket, all of those force, they were assumed to be applied at the same point, single point. Okay, and then what we did in a few moments ago, we find the resultant. Okay, in the other case, the resultant was 750 newtons. The other one was something else. Okay, but now what we're gonna bring to the table is what we call equilibrium. And what is equilibrium, Bruno? Equilibrium is when the resultant of all the force acting on the particle is 0. Okay, 0, meaning that, for example, we have the particle here, and once again we have F1, F2. Once we sum F1 plus F2, should be a 0 vector, or just 0. The resultant should be 0. Okay? And when we sum this and we get 0, then this is the equilibrium. The particles is in equilibrium, the body is in equilibrium. Okay, there is no force pushing, putting to the right or other one putting to the left. The resultant is going to be 0. And if you get, for example, that rule that we talk about, F1 plus F2, okay, plus F2, that's the vector, right? I just mentioned here. Whenever we have F vector 1, vector 2 right here, they're going to be S0, okay? So this is going to be what we're going to work today. And actually statics is pretty much equilibrium equations. Okay, that's what we're going to work a lot. So in 2 dimensions, okay, right now we just talk about vectors, vector 1, vector 2. Okay, vector 1, vector 2. Once we sum them, it's going to be 0. But we can summarize it as 2 equations here. What do we call the 2 equations of equilibrium? Of course, because we are talking about 2 dimensions, okay, 2D. And what are those equations? Well, it's logic. If we want equilibrium, we want the resultant to be an equilibrium, to be 0 actually. Okay, the body be in equilibrium, in this case, the particle to be in equilibrium. What we need is the x component and y components. Once we sum them, they should be 0. Okay, different from what we just did. What we just did, we said, hey, the resultant is 715 in x. Y was 0, okay, but x was 750. And we sum that vectors to find 750. Now we need to sum x with x, y with I, and both of them should be 0, meaning I have no resultant going to the right, to the left, no direction, just 0. And when it's 0, we say that's in equilibrium. Okay? So starting from this part of the lecture to probably to the end of this class, this course, this summer course, we're gonna always talk about equilibrium. And when I talk about equilibrium, force should be 0, the sum of the force, okay? The body should be at rest. Okay, there is no force pulling it to the right, to the left, up and down, rotating it. Once we go to bodies, okay, should be 0, equilibrium. All good? Okay. These 2 equations right here can be solved for the at the most 2 unknowns, generally represent as angles and magnitude. What does it mean, Bruno? Well, now, if I have a problem and then we have 2 equations to solve that problem, remember, if I have 2 equations, how many unknowns can we solve? We can solve up to 2 unknowns, okay? And what could be those unknowns? Those unknowns could be force, magnitude of force, okay? Or it could be the angles, okay? I could have a combination of 2 force or 2 angles or a force and an angle, okay? But I can solve up to 2 unknowns, okay? And to help us solving for the 2 unknowns, solving those 2 equations of equilibrium, okay? I want to really talk about you right here about free body diagrams, okay? Free body diagrams, okay, it's a way for you to visualize the problem, to visualize the problem. As you can see here, a large number of engineering problems that involves structures can be reduced to problems concerning the equilibrium of a particle. Okay, that's what we said. Many problems we can solve, okay, we can idealize, okay, idealize as a 2-dimension problem of equilibrium of a particle. And to do that, help us to visualize, idealize it, we use diagrams that it's called free body diagrams. Why? Why can we use these free body diagrams? Why are we going to use these? Well, they're going to just help us to visualize better. Because once you get the real problems, sometimes we have a lot of drawings, a lot of noise, okay? That is difficult for us to visualize. Where is the force? What is the angle? What am I talking about? So once you draw the free body diagram, a little diagram to help you visualize better the problem, okay? So for example, let me show you this example here, okay? We have 2 guys trying to try to lift actually this box, okay? Sometime when both are holding it, pushing it, okay? If you're not doing strength enough, okay, before starting lift it, that body would be in equilibrium, meaning that you have the force, and we have to put some um, force on the right and left to support that box without lifting, just to stay in a same position. This problem we call equilibrium equation, equilibrium problem. Okay, I mean that what should be the force that each one of those guys should apply to keep that box in equilibrium. Okay, once they lift from the truck here. Now, how can I solve this problem? Well, let's draw a free body diagram, because right now, right here, we may get confused how things are going. Okay. So for example, first step, draw the particle. Okay. Imagine to be isolated or cut free from its surroundings. So the particle is right here, where those cables are meeting together. And how can we draw the particle? Well, just draw point A, right here, point A. That's the particle. That's the point where the forces are acting. Okay. Let's draw the coordinate. Well, if the point is here, my coordinate is going to pass through the point. Okay, to help me to understand what's going to be positive, what's going to be negative in my calculation. Okay. Third one, let's include all the knowns. What do we know? Force, angle, dimensions. Okay. Here, we know the weight of the box. I was not giving here to you, but it's given, we know that. Okay, it's in the next page, actually. So the weight of the box, I know. Okay, I know that the weight of the box is trying to putting the box down. I have tensions on those ropes here, those cables. One I'm calling tension AC, tension AB, and actually this is step 4. We are including the unknowns. I don't know TAC, I don't know TAB, but I do know this is 30 degrees, this is 50 degrees. Okay, so from this problem right here, with buildings, with truck, with box, with guys, with other cables that for us doesn't matter right now, I'm changing to this free body diagram, a free body diagram to help us to visualize. So most of the problem, guys, try to draw the free body diagram, try to visualize what's going on. Okay, so that's why I like to just mention free body diagrams right now, okay? Because we're going to start working with a lot of force, a lot of different real problems, and sometimes just much better if you cut all this noise and get the free body diagram and work from here. Okay, with that said, let's take a look how we solve that problem. Okay, how we solve that problem. For example, how can we solve it? First, we're going to draw the free body diagram. Second, we're going to break force into X and Y components. Okay, X and Y component right here. And third, we're going to apply the equilibrium equations. Which equilibrium equations, Bruno? Well, the sum of the force in X should be 0, sum of the force in Y should be 0. After that, let's solve for unknowns. Okay, that's what we're going to do. Okay, and let's use that problem as an example. Okay, so let me actually copy this. Let me see if I can copy this. Remember, I can. Okay, so let's solve the first equilibrium problem here in this class. Okay, so let's take a look here. As shown above, the box was lying between two buildings and is now being lifted onto a truck, which will be removed. We want to determine the tension in each rope A, B, A, C. Okay, and the weight of the box is already given to you. Okay, remember, guys, let me just bring back last class yesterday. This is weight of the box, is not the mass of the box. Okay, this is the weight. Okay, this is the weight of the box. So for example, if this is the weight, the mass, okay, would be weight divided by gravity. Okay, if the mass is given to you, you need what? You need to find the weight. Okay, because we are working with newtons, force, newtons. Okay, just keep in mind. Okay, in those problems we are working with tension, force, all of that in newtons. So we are talking about the weight of the box, the weight of the objects. Okay, not the mass. This is the weight is given. In other problems, the mass is going to be given. Then you need to find weight. Okay, with this parenthesis. Okay, let's um, let's find what we need to find. First, draw the free body diagram. The free body diagram is already here, okay, for us. So no need to do that. Let's break the force into X and Y component. Okay, so let's do that once again. TAC, X, TAC, Y. TAB, Y, TAB, X. And this weight, it is only on y-axis, so no need to break it. It's already only on y-axis. With that, let's write the vectors. Okay, let's write the vectors with the sine, cosine, positive, negative, as we did just right now for the 2D vectors problems that we are working. So TAC, what do I have in TAC? What is the magnitude of this vector? I don't know. I'm trying to find it. TAC, and try to find it. Sine or cosine of 30? Well, 30 is being measured from x-axis, so cosine of 30. I had. Positive or negative? Positive. Positive direction, going to the right. Y? Y is going to be also positive. TAC, I don't know its magnitude. I don't know this is going to be sine of 30. J hat. What else? TAB. TAB, I don't know its magnitude. TAB. X component is negative because it's going to the left. Okay? Sine or cosine of 50? Well, 50 is being measured from x-axis, so cosine of 50. Positive and negative y direction, y component, positive, going up. TAB, sine 50, J hat. What about W, which is the weight vector? Okay. What is the x component? Well, 0. All of that is on x, on y, sorry. It is on y going down, negative 736 J hat. Sounds good? Okay. So what should I do now? Apply the equilibrium equations. Apply the equilibrium equations. Which equations, Bruno? Well, sum of the force in x should be 0. Then later, sum of the force in y should be 0. Two equations. Can I solve this problem using these two equations? Yes, I can. Why? Because I have two unknowns, TAC, TAB. Okay, there are two unknowns. That's what I need to find, TAB, TAC. The angles are given, okay? This one is given, but I don't know TAC, TAB. So I have two unknowns, two equations. I can solve this problem right here, right now. Okay? So let's do that. What is sum of the force in x should be 0? What is this? All of this should be 0. Meaning that TAC, cosine of 30, plus not plus, negative TAB cosine of 50. Should be 0. What about the next one? Well, all of these should be 0 once we sum it. TAC sine of 30, TAB sine of 50, 736 should be 0. Look what we have here, guys. What do we have here? A system of equations. Who miss math? Calc, what is it? Calc 1? Or I don't know. Does anyone miss math here? Okay. We have a system of equation. How can we solve a system of equations? Well, we need to write one of them in function of the other. For example, okay, see if you can visualize this, guys. I'm right for this one here. TAC is TAB cosine of 50 divided by cosine of 30 degrees. Can everybody visualize what I did? Can you guys write yes on the chat? Anyone at least? I think I can see the chat. I don't know if it is frozen. Okay, all good? Okay, awesome. Yeah, I can see it. Oh, nice. Okay, so system of equations. And what I'm going to do, I'm going to bring this bad guy here, or meaning this one here, in place of TAC. TAC is right here. TAC right here. Now, guys, please pay attention right now. This is where I got the most mistakes on the test every single year. Okay? Every single year. We are substituting this guy here where TAC is. And where TAC is right here. The second equation, meaning that this is going to be TAB cosine of 50 divided by cosine of 30. And this is where I got the mistake every single year. We cannot forget about the sine of 30. Okay? We're substituting just TAC. The sine of the 30 stays there. Okay? Now, I really want you to, right now, or stop this video right now, try to solve this problem here. We have just one unknown, TAB, TAB. So we can find TAB. How can you do that? There are a lot of options. You can do cosine of 50 times sine of 30 divided by cosine of 30. You're going to find a number. This number, TAB. Type sine of 50. Find the sine of 50. And then now you work just with numbers and find it. Okay? Some students like to make this calculation plus the sine of 50. Okay? They put TAB outside. And then later, 736 divided by the number. Okay? Let me go to maybe the easiest one. Okay, I don't have the step-by-step here in my notes, but I will do it right now for you. I'll do this calculation here. Cosine of 50 times sine of 30 divided by cosine of 30. I have 0.37. I put 4 decimal place here because it's not my final answer. TAB. What is the sine of 50? 0.7660 TAB. 736. TAB is going to be 736 divided by 0.3711 plus 0.7660. This is 1.113, 1.1371. 736 divided by this number. TAB 64726 newtons. And this is where a few times we're going to have different decimal numbers, or a few different answer. Because right here I use 4 decimal place to solve the problem. And right here at the end I put 2. But you can just use 2 here. 2 here make this 0.77, okay? Or you can just type all of these plus all of these is going to be giving a one number, and then you're going to round up that number. So that's where answers is starting to be different. And once again, there is no problem with that. Okay, it's just numbers that we are rounded up differently. Okay, so that's why it's important to me. It's important to me. Show me what you're doing, your steps. Show me your steps. Okay, show me your steps so I can understand where you got it wrong, so I can discount the right amount of points. If not, I'm going to give you less points. Okay, see if you understand step by step. Sounds good? I have TAB right here. Can I solve? Now, how can I solve for TAC? I'm not done. I need to find TAC. Well, then put it here in this side, guys. TAC is 647.26 cosine of 50 divided by the cosine of 30. TAC, let me see, 647.26 cosine 50 divided by cosine of 30. 480, 41 newtons. That's my final answer. Okay, I have a question here. Question, so you would prefer that we label each step to see how we get our answers? Yes, not label, like you don't need to show me 1, 2, 3, 4. Because in the homework, in the exam, I expect you to do like in order, like from top to bottom. Okay, here I'm going back to, like to the right, to the left, just because I have not enough space. Okay, so I expect you to go just like that. If you need to go back, you just show me an arrow. You're coming back to this equation here. Okay, but what I want to see your steps, I mean by the following. Okay, for example, you come here and write down this one here with sine of 30. Okay, do not just from here you just give me the answer. Okay? Show me the middle steps, meaning you put this here, there, write the equation. Okay, you solve this problem like this, like me, you put the numbers here. Okay, and then you sum them, put the number there. Okay, do not assume that I know what you're doing. Okay, that's what I mean. For example, okay, and just write down this one here. Some guys like to do the following. I'm gonna delete this, but let me, from this one, guys like to do the following. TAB is gonna be cosine of 50, sine of 30, cosine of 30, plus sine of 50. Some of you like to do that. Equals 736. I have no problem. Okay? I have no problem. But show me you're doing that. Show me that you're doing that. Because sometimes you're gonna miss it, you're gonna mess it up with some calculation here. So I know that you are trying to do this one, and maybe you mess it up with times here or the plus. Okay, so that's what I mean by showing your steps. But I do expect you to solve like from top to bottom most of the time. Okay, most of the time. So it's kind of a logic, and I can easily follow um, your thoughts. All good, Brian? Any other questions regarding this problem? So this is equilibrium equation. Okay, first problem that we are solving, equilibrium equation. All good. I think it's wonderful. We are solving this problem here. What time is it? Okay, we have a few more minutes. So let's go for problem number two. Okay, problem number two. If you guys don't have questions for problem number one, let's go for problem number two. Okay. I don't know if you're copying it or not. But this one is going to be good because we have this triangle once again. We have the mass, so we can talk about a bunch of things. Okay, so let me start. Determine the tension in cables BA, BC, necessary to support the 6 kilograms cylinder in the figure below. Okay, now 6 kilograms. I'm not talking about weight, not talking about newtons, talking about kilograms mass. So you already know tension, force, we work with newtons. So we need to change that mass to weight, okay? To weight. Um, and and after that, we're gonna write the equations of equilibrium, okay? Um, of course, you find the components of the force as well. So let's draw the. Can we draw the free body diagram together? Okay, just for us to visualize. Okay, free body diagram. I know all the force are being applied at this point B right here. Okay, B. I have right here TBC, tension BC, okay, TBC, and an angle 45 degrees. Okay, oh, I forgot to the coordinates. Okay. Coordinates, we know this is X, this is Y. Okay, what else? TBC. We also have TAB. TAB. I don't know its magnitude, but I have this triangle here. Remember what I mentioned? Triangle help us to find or the angle, okay, angle theta. Actually, angle theta is the same angle here. Or we can find the sine cosine already. Okay, the sine cosine for those over there. For this problem, I'm gonna use the sine cosine to do a little bit different. Okay, but you can also find the angle. I'm gonna also find the angle. Okay, before that, we also have another force, which is the weight. Okay, which I also have to find it. Okay, I have to find it. Let's start with the weight. Okay, let's start with the weight. The weight is mass times gravity. Weight here is going to be mass, 6 kilograms. Gravity, let's use, okay, 9.81. So the weight here is going to be, I have my notes, 588.6 newtons. So this is 588.6 newtons. Sounds good? Okay. So it was given the mass, but what I need is the weight. Now, let's find the angle or the sine and cosine. Okay, if we have the triangle which is well known 5, 3, 4, 5, we're trying to find this angle. Once again, you can find this angle using tangent. It's going to be 3 over 4. Angle is going to be tangent, inverse tangent, 3 over 4 is going to be 3687. Okay, 3687 is my angle. However, I can also use the sine and cosine already. Okay, what is the sine? Sine of theta. Sine, socadoa, opposite over 5. As the cosine, gsine over 5. Okay, so this is my other way to solve the problem, okay, with the angle. So we have two options, or we're going to use the angle, or we're going to use the sine cosine. Okay, doesn't matter. Doesn't matter. I'm showing you two ways to solve it. Bruno, and where should I use it? Okay, let's show. Actually, can I reduce this a little bit? So, yeah, let me try to write then right here. TAB. Okay. TAB, we have this angle theta that we already found, 3687. Okay. Once again, let's start. X component of this guy, right here, negative direction, negative. What is magnitude? TAB. Okay. The angle is measured here, so it's the cosine. This is the cosine of 3687, or 3 over 5. Oh, sorry. 4 over 5. Okay. 4 over 5. Positive TAB sine 3687. I forgot I hat, J hat. Or this is 3 over 5. Okay. Once again, sine 3687, 0.6, 3 over 5, 0.6. Okay, so they are the same. Okay, maybe some numbers a little bit the decimals, but they are pretty much the same. So there are both ways to solve it. Now, TBC, X component, positive, Y component, positive, magnitude, TBC, angle, this one here, cosine in X, sine in Y, TBC, cosine 45, I hat, TBC, sine 45, J hat. W, 0 in X, we have just Y negative 588.6 J hat. All good? Okay. Then we go for some of the force. Sum of the force in X should be 0. What do we have in X? TAB. Let's use the 4 over 5. So you can see it a little bit different. Of course, I could write cosine 3687, but I'm going to use the 4 over 5. So TAB, 4 over 5, plus TBC, cosine 45. Should be 0. Okay? Can I just write TBC as 4 TAB 4, 5 cosine 45. Okay. Sum the force in y should be 0. I have TAB 3/5, TBC sine 45, 588.6 equals 0. I'm changing TBC here. So I have 3 TAB divided by 5. Okay, or you can put the number there. TBC 4 TAB divided by 5 cosine of 45 times the sine of 45, guys. Please pay attention. It's really easy to forget about it. 588.6. So sorry, my hand drawing is not working so much. Okay, then we solve it. Okay, once again, you can have 3 divided by 5, then plus the 4 times sine of 45 divided by 5 cosine of 45. Okay, then this is going to be 1.4, 4.880.6 divided by this one. Okay, I'm going to put the answer here, so I want you to work and find this answer. Doing that, I found 420.43 newtons. Okay, by doing that. So try to solve it and see if you can get the same. Okay, use it step by step. Okay, go slowly, but I do want you to try it and see if you can get it. Then this one is going to be 420.43 times 4 divided by 5 divided by cosine of 45. 475.66 newtons. All good? Let me know if you have any questions right now, what I just did. Or if you are typing and you couldn't find this result, let me know. Okay, so the tension in the AB should be 420, and BC should be 475 in order to keep the system in equilibrium. Okay, I got a 1% is good. Okay, so I think we have time to finish the lecture because I have 3 more problems here. I will solve the 31, okay? And once again, I'm gonna leave the other 2 problems for you to work, so you have more things to do, okay? As I said, I really want you to try to solve the problems. I'll do my best to cover as much as possible during lecture. However, as I said, I will solve it and I will post later um, on Brightspace. Okay, I'll post this PDF fully complete. Okay, but you can check it out, but try to do by yourself first. Try to do by yourself first. Okay. Yeah, Brian said a little bit lost for a second. Got it. Okay, awesome. Okay, that's what I think you're gonna feel sometimes. You're gonna feel lost because really fast. Uh, and that's why I want you to put in pretext. Okay. So let's solve this last problem here, and then we are done for the class for today. And then you're gonna have two other problems to solve plus the homework. Okay, so I think it's gonna be a very good one. Okay, last one here for today. For a sailboat, a designer wants to determine the drag force that may be expected at a given speed. To do so, the designer places a model of the proposed hull in a test channel and use three cables to keep its bow on the center line of the channel. Okay. The manometer readings indicate that for a given speed, the tension is 40 pounds in cable AB. So we have the pounds for cable AB and 60 pounds in cable AE. AE, we also have um, information. So AB, oh, sorry, AB, AE. We need to find the drag force and the tension in cable AC. So this is unknown, and what is also unknown is this drag force here. That's what he's talking about. Can we call force D? Okay. So we actually have four forces: AE, AB, AC, FD, acting on this particle. Okay. So we need to find AC and FD. All right. So first thing, let's draw the equilibrium, not the equilibrium, the free body diagram. Free body diagram. Okay, let's draw the free body diagram. Right here, here. Free body diagram, well, let me already start with FD. We know that's right here, FD. Okay, let's start with this one here as well, AE, because it's already on y-axis. And this is TAE, okay? And it was given to us tension TAE 60 pounds. Okay? TAB was given to us TAB 40 pounds. And we don't know this one here, TAC. We don't know TAC. All right. Those are the knowns and unknowns about regarding the force. But remember, we need to find also the angles, okay? And that's why we have like alpha and beta right there, okay? And my question is, can we find alpha and beta? Okay. Well, let's take a look what we have. Okay, take a look here. Triangle 7, 4. Okay, yes, we can find it. Let me draw it right here. 7, 4, and this is alpha. The other one is, see if you agree with me, beta, this is 1.5 and 4. You guys agree? Right angle right there. Right angle right there. How can I find it? Alpha inverse tangent, okay, 7 over 4, beta, inverse tangent, 1.5 over 4. You guys agree? All good? All good? Okay. By doing that, let me see. I have 60, 26, and I have 20, 56. Okay. This one, 60, 26 degrees. This one here, 20, 56 degrees. All right, now I'm good to start the problem, okay? Because I found the angles, I wrote the force that I have, the unknowns. Now I can start, okay? Let's start by write the components. TAC. What about TAC? Magnitude, no idea. But I know its component is going to be positive and positive, okay? Now pay attention, guys. 20 degrees right there. It is touching the y-axis. Measure from the y-axis. If I use this 20 degrees, in x should be sine of 20, 56. And the cosine should be together with the y-axis. Okay? Bruno, can I find the other angle from the x-axis? Yes. 90 minus 20.56 would be 6944. Okay, so you could use cosine of 6944, sine of 6944. It's going to be exactly the same thing. Okay, or TAB, same. Okay, however, its component is going to be positive in y, negative in x. Okay, TAB, negative. Now, same I said, sine 60, 26 degrees, positive TAB, cosine of 2056. And actually, sorry, my typo here, TAB is known. So TAB is 40. Let's put already 40 here. Okay, 40. TAB is known. So far, so good. What about FD? D, positive FD, I hat, 0. Positive direction, only FD, 0 in J. TAE, 0 in X, negative 60 J. See if you agree. All good? Sum the force in X, TAC, sine 256, negative 40, sine 60, 26, plus FD should be 0. Sum of the force in Y, TAC, cosine 2056, plus 40, cosine of 50. There's a typo here, guys. Please let me know when I have a typo. 60, 26. If you got it, please let me know. Open your mic and just tell me. Let me go back here. So this is 40 cosine 60 26 degrees, negative 60 equals 0. And if you don't agree with anything, please let me know. Okay. And then, guys, in this one, particularly this one, take a look at y equation. We have TAC as a known, but this is known, this is known. So this one, we can solve it really fast. Okay, we don't need a system of equations. So that's why it's a good idea to write down the both equations before you jump to a system of equations. Okay, before you jump like writing one variable to with respect to another. Okay, because this one here we cannot solve direct, but this one we can. Okay, this one we can. We can save some time. So solving this one is going to be TAC cosine. Okay, doing this calculation, in my notes I have 4016. TAC, I have 4289 pounds. Then I will go back over there, substitute. At the end, I will find FD 1967. Oh, 67 again. Okay. And that's it. You find FD. Okay. So please, guys, most of the calculation here are just escape showing, and I escape putting the calculator. So probably you don't have time to put in your calculator. Following with me, please do it. So maybe after class you're gonna go lunch, okay, and then you come back, just type in the calculator. Okay, let me know later by email or anytime if you're not getting what I got. Okay, and if you're watching it, the recorded lecture, please stop. Never I'm doing calculation and do the calculation together. Okay, guys, how does it sound? It's okay. I know it was a bunch today, but it looks okay. All good. I'll leave two problems here, as I said, for you to solve by yourself. Okay, they're not difficult, it's just pretty much what we did. Okay, but I will solve it this afternoon, and then in this afternoon, together with the recorded lecture, I'll post the completed PDF on Brightspace for you. Okay, and then tomorrow we can go to lecture 3 and get on track. Okay, so let me just finish here the recorded lecture. If you have any questions, please let me know. And then I see you tomorrow.